But slowly the whole idea is that the navigation system in the future would be all satellite based. You don't need to put VOR, you don't need to put ILS. All you need to do is put your monitoring station, uplink it, and it can be used. Hello ladies and gentlemen, your captain speaking on flight deck. My name is Captain Surendra Singh. Welcome aboard the plane talking. Sit back, relax and enjoy your journey. Okay, we will start with what you call it Gagan. They started working on GPS and it was used for aviation purposes also. But the accuracy of GPS was not adequate for to do a precision approach, because standard positioning service is what? Plus minus 15 meter, plus minus 50 feet. And if you see your Cat 1 minima, Cat 1 minima is 200 feet, correct? So for 200, your accuracy plus minus 50 feet, you may be hanging on the tree. So the accuracy, what was available, it was not sufficient to do a precision approach, even for the Cat 1 approach. And so somewhere they made little modification in this. And the term which they gave was DGPS. This term is not used anymore. Differential GPS. Now why? Basically to improve the ability of this equipment so that you can do it for precision approach. Basically you don't need ILS for Cat 1 minima. The accuracy, whatever is there, it is sufficient to do the approach. That was the whole idea. So later on, this name was replaced with something called augmentation system. Augmentation, the nearest word to augmentation is augmentation. Very good. Okay. Augmentation is improving something which is adding on to something which is already existing. You have lift augmentation. You design the wing, it produces the lift. You can improve the lift by lift augmentation devices. Lift augmentation devices are flaps, slats, slots. We study in principle of flight in technical. So augmenting something, improving. Now how did they improve it? And they named this differential GPS. Initially they used, so all the books which were written in 80s and the beginning of 90s they were all talking about DGPS, differential GPS. Later on, this term was basically replaced with something called augmentation system. This augmentation system was to improve the capability or accuracy of the system which is already working. And the idea was to bring down to the Cat 2, Cat 3 approach also. So you don't need any localizer, you don't need any glide slope, nothing. You have onboard system by which there is an approach, okay, which you can follow. You have a localizer also and you have a glide slope, and that is provided by the GPS. You don't need anything on the ground. But initially they did it at the smaller level. That was called LAS. LAS stands for local area augmentation system. It means at a particular airport, if it is certified and if the aircraft is certified and the pilots are cleared, they could use it, this system for landing, augmentation system or DGPS. Or it was Waas. LAS is local area augmentation for a particular airport. Waas is wide area means number of airport can use. In fact, there was also initially when they gave DGPS this term, they made it a little different name. They said it is, which is still used, ground based augmentation system. They made it, put it on the aircraft, airborne ABS, airborne augmentation system, and then they have space based navigation system, or space GBAS is or ground based augmentation system. So the whole setup was on the ground. Particularly if you are doing vertical guidance, basically if you are using the glide path guidance, you can't be plus minus 50. You can't be that your decision height is 200 feet and you're going below. So the local area augmentation was based on ground based sensor equipment. Wide area is SBAS. SBAS stands for space based augmentation system. So Gagan, which we will discuss, It is basically part of this. I'll also explain you how this works. Not used anymore, but initially American started using for themselves. So they had airport which was certified for Cat 1 approaches. If aircraft is modified for that, you don't need any ILS on ground. With the onboard GPS system, you can do the approach. Whereas Gagan, GPS aided geo augmented system. GPS aided, okay, means it is aided by GPS. Augmented, obviously, it is augmented. Air navigation system, augmented. So, what they did was this accuracy of standard positioning service plus minus 50 feet is not accurate, and you want to use it as ILS, which gives you lateral guidance and gives you vertical guidance also. So, how to improve the signal? This things was very simple. You are receiving signal from satellites, which is giving you your position. Correct? That's what you are receiving, but not accurate. So you have to improve the accuracy of the signal. So what they did, they installed antennas around airport. So let's say they put the antennas. The exact coordinates of these antennas were known. Let's say this antenna placed, on the ground where it is. It is at XX degree, XX minute, and XX second. Very accurate position. You know where you have installed. I will take an example of one antenna, but wherever you have installed that antenna, exact position is known. Now, so that is your actual position of that antenna. What you are receiving from the GPS, let's say you are receiving the signal from GPS in this area, and GPS position shows is XX degree, XX minute, and XY second, because it is just in few feet. You want to improve that plus minus 50 feet also. So maybe few seconds, there is a difference. So that is the error, and they exactly know how much is the difference. So what they did, they deduced this error, how much is the error in this area, and then they installed, and the all antenna were connected with the transmitter. Means this antenna is also connected, this antenna. So exact how much is the error in that area. A correction signal is made, and that signal is transmitted in VHF frequency in all the area. So at the aircraft, if your aircraft is modified, it is receiving GPS signal and it is receiving the augmented signal. Now life is wonderful. But obviously, the airport has to be equipped with all this equipment, antennas and this, and also the navigation system also should be modified to receive the signal, and it can be processed on board. And plus, you need a pilot trained to execute that kind of approach, and they were using it till Cat 1. But only all those aircraft which are certified, modified, and then they can use it. But only at that airport. So they had certain airport where people could do DGPS approaches. That was called DGPS. But actually it is a ground-based augmentation system. So what they have done, they have seen by putting those antenna how much is the error. They corrected for that error. Now they are transmitting locally in that given area, maybe 50 mile or something, or 20 mile, an aircraft coming on an approach, you will get your correct position, and that could be used for landing. Okay, that is ground-based augmentation system. So the setup was something like this, correct? Some airport is there, so they have put those VHF, so you have those GPS receiver all over. Let's say San Francisco airport or whichever airport, they want to upgrade it, so they put the antenna. All these antennas are obtaining GPS position, they know their own position, so what is the correction required? And that correction is transmitted by they are all connected by a VHF data broadcast. Now it is a VHF, obviously it has got limited range, maybe 50 mile, 100 mile, wherever you want to use it. You get it? So the aircraft which is coming for the approach, It is receiving GPS satellite signal also and the augmented signal also. Wonderful. You could use it for making an approach. So the concept was simple. You put all over those antenna to see GPS, to receive the same signal which aircraft is receiving, compare it and then send an augmented signal. But that augmented signal is in the VHF frequency, only in the local area. That's why it was called local area augmentation system. Then they further improved it upon by like this. This is wide area augmentation system. Now wide area, what they did, they put those receiver antennas all over the United States of A. All they chose, let's say this 50 airport or so many airport will have their receiver antenna, whichever they want to upgrade it. Now all those, they have those reference stations where they are receiving the GPS signal and their actual position is known wherever that antenna is. Now they are uplinked with, or they are linked with a master control station, and that master control station, earlier you were sending signal from the ground. Now that correction signal is transmitted through a additional satellite. It is not your GPS satellite. Okay, GPS satellite is already existing. So whatever that area on the United States of A, or whatever the airports were there, or you wanted to put this system, to put your monitoring station, all those antennas, they are seeing how much is the actual position, how much is the error, correct? Now they are uplinked with a ground station on the earth, and now this correction signal is not transmitted by antenna on ground, it is transmitted by this satellite. Now any aircraft which is making an approach here or making an approach here, if the aircraft is certified, basically that it is modified for the Waas operation, pilots are trained, airport is there, use it. You don't need ILS to get it to Cat 1, Cat 2, Cat 3, that's what it was. India also started working on this project called GPS aided geo augmented navigation system. That is a full form of this. It is exactly working on the same principle. So we also created something like that. Remember, the augmented signal is by the additional satellite, which is not GPS satellite. It is a communication satellite. So they installed, initially it were 8, then they increased to 13. Yeah, by 2006, they had almost 13 reference station. So they put those antennas. So those antenna exact position is known. You are receiving from satellite also, you know the error. Now they put the station. So all they were linked with, one in Delhi, one in the master control station in Bangalore. So there were 3 agencies involved with this, one Airport Authority of India, DGCA and ISRO. And obviously you needed all the data and everything. This was outsourced. There is a company called, which one that? Radan, Messrs. Radan company. So we have our own satellite. So basically that satellite we are using as a platform to give the augmented signal. Okay. And it is GPS aided. Remember, it is GPS aided. So we have not made a GPS. Geo augmented. So it is augmented signal. So what they did, they put those all. Can you see this monitoring station all over India? That's how they put those monitoring station, and then they have the one. There were 2 in fact uplink station where they all were connected. This is the diagram which actually is showing that wherever the signals you are receiving, you have those antenna placed, master control station, they are interlinked, and then you have your own communication satellite. So from there it goes to Bangalore, whatever the master control station, and it is uplinked to the GSLV series satellite which we have. So basically we have taken all the technology from US, the frequency L1, L5 frequency, the structure or model of ionosphere, that also has to be factored into, so that also we take all that. We have only our satellite, nothing else. Otherwise everything is basically the equipment and the augmentation system is outsourced kind of thing. Clear how it works? So now all those airports which were equipped with this, and the aircraft is modified. So aircraft, if Airbus or Boeing or ATR or whichever aircraft wants to use it, that's to be modified. Then there should be a approach, published approach, and the pilot is supposed to be trained. It's very simple, correct? GPS is there, whatever the constellation owned by Americans, it is working fine, no problem. We put our own monitoring station connected with the uplink station. The two, in fact, one is, and they're controlling a GSLV satellite. That is your Gagan. Okay. So that is the footprints, what they call it, of the coverage area of Gagan. So you can see it is well, goes up to Australia. Here also it is going, crossing Middle East up to South Africa. So that is a footprint of Gagan. Means in all this area, if you put the installation of your ground transmitter, this equipment can be used. So like this is the example. You have those geo satellite which are geo because a satellite which is there, that is a geo satellite. You know, geostationary satellite which remain at the same point. So this our satellite GSLV series which is working, it stays there only and send the augmented signal. This is again the space-based augmentation system. This is Waas, what they call it in which Afghanistan? Okay, America. So that is Waas, that is European. Okay, EGNOS. This is Japan. So that was already before Gagan was put it into the operation. And all these systems are interoperable. Interoperable means if my aircraft is modified, you don't need to modify for American for the Waas, or you don't need to modify for the EGNOS. Remember the so in India there are many airports which are since 2015 it was certified for use. I think last 2 years back there was a demonstration landing on the Gagan, and slowly aircraft need to be modified. Obviously there is a finances involved. Aircraft equipment will be modified. After that, that would be certified. Then the pilots need to be trained. So it's a long drawn process. But slowly the whole idea is that the navigation system in the future would be all satellite based. You don't need to put VOR, you don't need to put ILS. All you need to do is put your monitoring station, uplink it, and it can be used. So now there is seamless operation. If an aircraft takes off, actually this is the old picture. If you're taking it from here right up to, it can be used for navigation also with a more accuracy. So anywhere you can use this system. Like I said, that was the old thing. This is, you can see there's an overlap between different whether it is a Waas or EGNOS or Gagan or MSS. So whatever this, you can see those color wise. You take off from here, you go anywhere in the world, you have augmented signal available. So that is your Gagan. Indian ISRO with the Airport Authority of India has implemented this GPS aided geo augmented navigation system. Now the objective was to establish, deploy, certified. Basically it is certified. You are cleared for Cat 1 approach. Eventually to bring down to Cat 2, Cat 3 also. But in India up to Cat 1 as far as I know. Augmented system for safety of life civil aviation application India has been successfully completed. The system has interoperable with others. Like I told you, the three are already existing one, so it can be used. There is no need that if you have this equipment modified, can be used anywhere with this system. So it was certified by RNP1. In one of the class, just for video, I will teach you RNP, RNAV. It is not part of that, but for airline entrance. Okay. RNP means is more accurate, 0.1 nautical mile accuracy. Okay, even for the en route navigation since April 2015. Better air traffic management. So the project has established, now I think there are more. What it says, old information, 15 Indian reference station. So everywhere they put those reference station, and then you have 3 Indian navigation uplink station. From the satellite, the data can be uplink. 3 Indian mission control center. Okay, and installation of the associated software and communication, and the accuracy is up to, which helps the pilot in the Indian airspace by accuracy of 3 meters, roughly 10 feet. So the implementation was done with the system over Indian airspace, Waas, whatever the equipment they were using, codes for L1 frequency, which was obtained from United States Air Force by Department of Defense. That's what somewhere 2005 when they actually started working on this. And it was given to a company that measures rhythm. GSAT-8 are satellite, one satellite which are using this, and GSAT-10, GSAT-15. So this is about your space-based augmentation system. So Gagan is actually as-base equipment. So with this we have finished GPS and Gagan. See you in the next class. Till then, yeah. Till then, stay tuned. This is your Captain Surendra Singh.